Hello, people, and welcome back to another episode of Dco Codes. This time we're talking about Project Euler Problem number 36. Um, Double base palindromes. So, as you can see in front of us, we have this old, hideous thing. Um, where to even start with this? I'm going to start with talking about the solution and how we can just kind of tidy it up visually, if nothing else. So, first of all, we're just going to start with the refactor right away. We're just going to space everything out so it doesn't look like a bunch of janky crap. Now, lol, this is because why would you take the string, you cast it to a string, that's A, and you immediately take it back. So don't do that. That's silly. So we're going to fix that. And, just when you have arbitrary values like that, like nobody's going to know in any sort of professional capacity, like what that range, why that range is like that. Now they might if they looked at the problem and they if they were familiar with the problem coming in, they might have an idea that this is supposed to be a million, right? It's the range is arbitrary, but in a more professional setting, you want to at least be clear in some way about what it is, just what it is. 1 million doesn't mean anything. It's a maximum, obviously, right? So at least we've cleared up one tiny thing about it. But the point is just that, you want to minimize these places in your code where you're just using random values that nobody understands, right? Like this looks like one of those situations too, but anybody that's used this combination of functions knows that when it puts out the binary string, there's two sort of characters at the start that denote that it's a binary string, and you just want to kind of slice those away. So that's why that's like that, right? But again, it's one of those arbitrary things. Now, you wouldn't want to, in this case, make a constant for that and move it out, because that doesn't really help anything. It's really kind of one of those, you can't make this any cleaner without using an F string, as we'll see in a second. So yeah, this is about as clean as this solution is going to look as it is, right? So we've cleaned it up. We've refactored the original thing. It's a bit more human readable. And now we're going to see what happens. This is, like I said, this B, don't ask me why B is being defined before A. If you want to keep yourself sane, you would take the time and do something like that, or keep someone else sane, you would do that. And I think I have not done that moving forward, so we're just going to drive yourself crazy. So as you can see here, we've got an F string now instead of the cast and the slice, right? It's slightly slower, as we'll see here. This takes, for 10 iterations, this is taking 3.5 seconds, and this one I think is like 2 and change. So the F string, no, okay, I was incorrect. I'll run it again just to be sure. It is slightly faster to just take the slice than the F string, but the F string, in my opinion, is cleaner when you know what the colon B part of the F string is about, which is just converting the X decimal value to a binary. It looks cleaner than the other way. The other way is like, what is this 2 and the slice, and what am I doing that? So next, we'll move on to tidying up the palindrome check function. So here we've just sort of better named things. So, a palindrome is not exclusive to numbers, right? It could be a string. And because we're expecting a string anyway, there's no reason to, you can leave it as a single letter name, but it's better, in my opinion, as much as possible, when they're not dummy variables like this index variable, to give it some kind of meaningful name. Because these days when you compile it, or whatever happens, when you bundle it up and put it into production, it's going to be minified in a lot of cases, or if it's all done under the hood now. It doesn't matter how long your variable names are, honestly. You're doing nobody a favor by using single letter variables in any sort of capacity where you want people to see your work, right? If you want someone to understand it, if you want to minimize the amount of commenting that you have to do, it's usually advisable to be as clear with your structuring and your naming conventions as possible. You'll notice I often use an is underscore whatever to denote a Boolean, right? Is this something, yes or no, right? You'll find it's in terms of clarity, you'll want to pick naming conventions that are similar to the language that you speak natively, right? So we've named a function is palindrome because it's a check. It returns a binary. Is it a palindrome? Yes or no. Um, naming your functions and your variables in ways that kind of naturally come linguistically to you is a good idea. It makes things more readable for everyone, even people that don't code, right? It kind of bridges the gap between programming and pseudo programming, as it were. And that's kind of the era we're in with AI and everything like that. If we can get so much further just being able to serve talk in pseudocode, right? If people can get used to the logic and saying it in English, AI and other coders can take us the rest of the way there if we all kind of meet in the middle. So this version, I mostly want to check to see if taking the division out of the while loop did us any favors. So let's find out, right? Because that's kind of the expensive part, is going through the while loop. Now you'll notice we only iterate over half the string, right? Because if the first half matches the back half, well, that's the palindrome, right? We only have to check half the string. And that's why you might have noticed I'm not using a string reverse function, which would have been the no-brainer, right? If, is A forward the same as A backwards, just use the reverse, and away you go. And same with B, right? You do it for both. But in this case, we're just going to quickly check to see. Did I run that? I think I did, but I'm going to run it again. 2 point something seconds. No, it's 3 now. Is that true? Yep, 3.5-ish. 3.6. Oh, I might have gone the wrong direction here. Okay, yeah, 2.25 versus. And we'll just do it one more time just to check. Sure. Yeah, so this actually, doing the division outside in advance apparently does no favors. If anything, it actually hurt a little bit more. So, sometimes it seems very advantageous to do some of these sort of mathematical operations or computations, in advance, but other times, apparently, for whatever reason, it doesn't pay. So I guess the lesson here is to sort of don't sweat the small stuff. You can do it, I suppose, if you think to do it and it makes sense to do it, but I wouldn't do it as a strict habit. All right, so we've put the division back in. And now what's silly about this one? I call this the silly one. This is because instead of checking A and then B one at a time, we're basically passing a list of A and B, mapping it through the is palindrome function and checking if all results are true. Does this do us any favors? I'm pretty sure no. Yeah, so it's basically another 100% 50% fast or slower than than the previous. So that's doing us no favors. What if we do this? Now this is basically what we just did, except now we can kind of put the whole solution into a nice clean list comprehension. Okay, super duper. And we can also pass any number of palindromes into this. So it's usable for other things, right? So now we have two sort of utility functions, is palindrome and are all palindromes, right? So those are useful if you need to do a bunch of palindrome stuff outside of the solution function, right? If you had other applications for these prototype functions that you have, right? Now, how does that do for us? Any favors in terms of speed? No, it's even a little bit slower, I'm guessing. Okay, so what if we try just a regular sum, but with our independent, is palindrome function checks? And that comes, ooh, that's nice, actually. Is that our fastest? I think 1.48 for 10 iterations, so 0.14 seconds. Okay, well, so this one, I just went ahead and used the string slice reverse strat, as you can see here, to see how fast that would go, because until now, we've been avoiding that because we thought, oh, we're smarter than that, we're above that, that's too easy. We're just gonna check half the string, and if that works, then we win. And I guess we could do that too here, right? We can say we could slice half and then the back half, But I mean, as you'll see here, what's that? So it's almost 1.7 for 10 iterations. Again, 1.6 for 10 iterations on that. This one, the previous one, what was that again? That was about 1.5. So, I mean, this is slightly faster at the moment, it looks. But in terms of like effort, right? This one is way cleaner looking compared to having this extra check function to do all the heavy lifting. Set to the side. This one actually kind of, if you know what those slice strings are, and you can always wrap these in a function too, right? Even the check, you can put that, you can make that your is palindrome check, right? You can just move that into a function. And it will cost a little bit of overhead, but if you're going to use it in more than one place, like I was saying, like over here or outside of the solution function, that'll be a useful thing to do, right? So yeah, 1.6 seconds of that one. All right, what else we got? So this one, you just crammed it all into a sum. And look at that. About a second for 10. So 0.1 seconds, 0.09 for one iteration this way. Well, what about a whole other approach? Now, this is still a brute force approach, right? We're going through all possible numbers and seeing if it's first a palindrome decimal, and we're checking to see if it's a palindrome in binary. Well, we know something about what a palindrome is, right? We don't have to just, take our chances with, a given number between 1 and a million. We can build our palindromes, right? Now, this is a lot more work. Look at all this. I got all this stuff here. Here's the solution. We'll just minimize the solution for a second here. So we have a generator here that can generate a decimal believe it's half of a palindrome. So basically what we do is we just build half the palindrome, right? So now we don't have to iterate through half the numbers in effect, or square root of the possible combinations, right? So if it was a million, we only have to go through 1,000 combinations now, right? 999 plus a middle digit. Wait, no. Yeah, so it's kind of like, that's a bit confusing because, a palindrome could be an even number of digits or an odd number of digits, right? And if it's an even number of digits, there's no middle digit. And in an odd palindrome, actually, that's a good point. We still have to check. Okay, so what I was thinking is, in an odd numbered palindrome, it doesn't matter what the middle digit is, right? They're all going to be, as long as the first series and the last series are mirrored, the middle digit doesn't matter. So it's like, oh, does that help? It's like, well, not really. We still have to go through all 10 of them, which is what you see down here. The middle digit is just going to take whatever it is. We have to compute the proper palindrome in whatever base we're talking. In this case, we're talking 10, base 10. And then we check to see if the binary version is a palindrome as well. Now this one, when it runs, super fast. Look at that. That's for 10 iterations too, right? So that's, that's a huge improvement. Factor of 10, almost 100, right? So that's unbelievable. Obviously, that's the way to go. Now, this is obviously a lot more coding, right? You had to figure out the generator. So you got it's a recursive generator at that, right? That actually took me a little bit to figure out because it always seems easier than it is. And then it seems really hard. And then you figure it out and say, okay, look how clean this is, right? So this can actually be cleaned up, but this is your sort of termination condition. If there's no digits, you don't give anything. And that way, when it returns, it just tacks on an empty string. But otherwise, it basically goes through all the available digits and then kind of does the leading digits one at a time and then tacks on the next digit from this iterator here, right? So just to be clear, we go through all the last digit possibilities, and then for each of those, we go and we generate the leading digits for one less digit than what we're currently on, right? So it's a recursive thing. And then it goes in and it tacks the two together. So if we had 3 digits we're looking for coming in here, this is digits equals 3, and we're going to make it in base 10, so the maximum digit is 9. Just ignore this for the moment. We go through the last digits all, either 1 to 9 or 0 to 9. That's what this starting digit's all about. And then we go through these. So if this is our third digit of the 3, this will then do digits minus 1, which is 2. So it'll generate the first 2 digits, right? And then it'll stick them together, right? And so if it was in here, we said 3 minus 1, that's 2. Pass the 2 into here, right? So now it's going to do it again. We're not worried about that. So we're at 2. Starting digit, if digits equals 1, well, we're not at 1, we're at 2. So the starting digit is going to be 0. Max digit is going to be 9 plus 1. So it's, the termination iteration is going to be the 10th. And so, yeah, we do it again, right? So digits is now 2, minus 1 is 1. Pass it in. We know that it's going to just spit out 1 through 9 at that point. And that'll be your leading digits. And then it'll tack on the last digit. And I'll just go pass that up. So it's building it from the front to the back, right? And then that's what this front half is. Middle digit starts by default as nothing. And then we get the back half just by reverse stringing the first half. And then we have this sort of, I don't want to say, it's not anonymous, but it might as well be anonymous. It's just a sort of dummy function that it takes the front half, the back half, and when it gets the middle half, puts it all together and gets the decimal value, because that's really what we're concerned with, right? We have to sum all these palindromes, valid palindromes together. So basically, if it's not a valid palindrome, we're going to sum 0. But if it is a valid palindrome, we're going to sum the decimal value of it. All right, so the meat of the program here is really, now we've got it able to generate the digits and compute the valid palindromes. We just go through all the possible combinations with this and this, and then we combine them together based on whether it's even or odd. So this is if the number of digits we're counting is even, right? So n is the number of digits in the palindrome that we're looking for. If it is an even number, all we do is compute the valid palindrome. We don't worry about the middle digit at all. It can stay nothing. And then we just add it to the total if it's valid. And similarly here, we do that, except we set the middle digit to whatever that is in D in the range of 10, for D in the range of 10, and we sum it all up. Now, how fast is that one again? That is about, was that 1.3 milliseconds per iteration? What about this one here? What is this one? So the only real difference, I think, in this one, if I recall correctly, is that I tidied up this little bit. So you have to pass in the middle digit now. The back half and front halves are still kind of hard-coded to when this function is defined, right? This is called a closure. When you have a function that's defined and it captures the scope above it for purposes. In this case, the purpose is to capture the front half, back half variables. And so we do that. We need to sort of redefine this function every iteration of digit generator and so forth. Because if we didn't, we'd have to pass in those strings anyway, right? So it's kind of the same thing, to be honest. Like the only difference is you have to kind of it's going to redefine this part of the function each time. But because it's only in the one place, theoretically, it shouldn't be duplicating a lot of code internally to make that happen. And you can see down here, I kind of tidied it up. I didn't want to have so many indentations at this point, so I just stuck everything into a sum and went off the edge of the side of the thing slightly, which is not ideal, but it's not the end of the world at this point. And you can always kind of put this on a new line or something like that to tidy that up. So let's see how this one does. So it's similar. It's basically the same, maybe a tiny bit faster. And that's fine. I mean, like I said, I mostly did it just to make it a little bit tidier looking. I've already painted over there. Okay. So now I got one more, I think, that's just slightly different. What is the difference? Just be clear about the stuff at the top. So what this stuff here does, the solution, I mean, as you no doubt have noticed, I was building the palindromes from the decimal point of view. I considered what it might be like to try to build it from the binary point of view, and I made that option available in this version. So isDecimal is a function when you run this, theoretically, if you had a command line parser or whatever, you would pass in maybe the flag for what base in decimal or not. If it's not decimal, it's obviously we're building the palindrome binary. But in order to do that, we need to know what the maximum decimal value is for one of the palindromes. Right? It's still the same limit, which is 1,000,000 in decimal. You have to convert that into binary, right? Which is what happens down here. So if in decimal is true, we just count the number of digits in maximum decimal value, right? And we've done it in such a way that that constant sort of determines the length, right? So we don't have to hard code those things. Now, this is a really easy calculation to get away with. So, you can kind of keep it open-ended like that instead of just putting 6, right? Because the maximum digits would be 6, right? That's what it's going to come up with. But in binary, when it's in binary, you have to kind of do the little thing anyway. So I just kind of did that way, just so everything hinges on this now and this, right? This never changes, and this can change, right? Based on your use case. So this never changed, so we'll just ignore that. Is palindrome, like I said, you can move that into its own function, which we did. We can just kind of scoot that away. Compute valid palindrome. Now we're passing in the front half, the middle digit, the back half, and we're specifying a limit that defaults to maximum decimal value. Maximum decimal value is what the problem defines as, again, 1,000,000 or 99999. And then, we check to see if it's a valid palindrome, which we do with that function there, right? And it depends on if it's in decimal. So we're checking that initial state up here in decimal. So if it's in decimal, we're going to just convert to binary right here. I don't know why I can't see my cursor. And then the other one, if it's decimal, we just leave it as a decimal. But we have to convert to a string to check the palindrome nature with the string slice strat. And then based on whether or not it's below the limit, because if it's a binary, if we've taken a binary palindrome and converted it to a decimal value, we have to make sure that it's below that limit of this, right? Because, we could theoretically make a binary palindrome that is above that if we're just worrying about the length of the palindrome. Once again, you can see we're back to this list comprehension strat. The only reason is, I think, because it was going off the edge. No, they're both terrible in terms of length. So whatever works. Oh, it's because we're passing in all the strings now. I do not believe the list comprehension really affords any favors at this point. Most of the losses now come from the fact that we have two options. You can do it in binary or decimal. The binary way is slower. The reason is that there are going to be more binary palindromes because there's more digits. There's 20 digits under the limit here. So you can have a 20-digit binary number. So you're going to have that many more palindromes that you have to build. And that's why actually doing the decimal way turns out to be the fastest. You build the decimal palindrome, and then you check that it's a binary palindrome. And then you take that, and you shove it in the thing, and we see if it does it. Let's see if you do it. Take the thing. Ding. All right, well, thanks for coming out. And don't forget to have your children played and tutored. Have a good one.